Okay, so LP2. So we've got, let's draw the picture here, of 2 points over here, 5, 3, and 2, 8. So there's our 2 points, and we want to find the equation of this line through here, that line L. So as somebody recommended, we can take the difference of these to find a, yeah, that's right. No, it doesn't matter. It doesn't matter. That's right. It's a good question, and it all it'll do is give you, that vector instead of that vector, but they're both parallel, and that's all that really matters. Yeah, in this case. So let's. I'm just going to do it this way for arbitrarily, and let's call that vector v, and it's the difference. So let's see. It's 5, 3 minus 2, 8, so it's 3, negative 5. Okay. Right. Now, our goal, though, is to find a vector perpendicular to that. And here's a nice little trick. If you want to find a two-dimensional vector perpendicular to a given two-dimensional vector, all I need is for v dot in to equal to 0. So, by the way, I wish I had thought of this myself. I didn't. Somebody showed this little trick to me. Take these two numbers and just switch them and change the sign of one of them. And it'll always work. Because you got 3 times 5, then you got 3 times 5, but with a minus sign, and it adds up to 0. So, cute trick. I'm a big fan.
So switch them and then change the sign.
Switch them and change the sign of one of the coordinates.
Either one?
Either one. Now, if you see here, I started off with kind of with a minus sign here, and then I changed the sign of that one, the first one, and that's why effectively that gave me this one. If I had kept that minus and changed the sign of the other one, it would have just given me the other perpendicular vector.
So that's 3.
Yeah.
I can't really see this. 3, 5.
Oh yeah. Let me. Sorry. So let me write that a little bit better. So you start by switching these two coordinates. That gives you negative 5, 3, and then you got to change the sign of one or the other of these numbers. And since I like positive numbers, I'm going to change the sign of that negative one, thus making it positive. So we've got our normal vector, 5, 3, and now I need to find a point on this line. Oh, I've got 2 of them. I can choose either one. It doesn't matter. 5, 3, and 2, 8. So I don't know. I guess 5, 3, whatever. We'll call this x naught. So the equation of my line is n dot x equals n dot x naught. So let's see, my normal vector was 5, 3. Okay, 5, 3 dot xy equals 5, 3 dot, let's see, my x naught is, 5, 3. Okay, what are the odds? That was inadvertent. And altogether you get 5x plus 3y equals 34. Yeah.
Why are we not using the parametric form of the equation?
Because the problem is to find an equation. So parametrizing a line is really kind of a different thing. And in a problem, if I say find an equation of a line, I want this, right? If I want the parametric, I'll be very explicit about that. I'll say, parameterize the following line, or find a parameterization of the line. Or now, I might at some point give a vague, sort of up to you, fielder's choice kind of thing, where I say, write down a function that relates to the following line by whatever construction of your choice. At which point, you can choose whether you want to parameterize it, or maybe you want to find a function whose graph is that line, or maybe you want to find a function whose level set is that line, or maybe you want to find whatever. Lots of different options there. But when I say equation, I'm talking about this. Yep.
If I did the parametric equation and then find the symmetric form of it, should that give me that?
Well, symmetric form, there is no symmetric form for lines in R2. So critically, this is in R2. See, it's in the XY plane. The symmetric form is for when you have a line in R3. Yeah. And so I would, if this, for example, if these were 2 points in R3, then the problem would have to read, find the symmetric equations for the line in the XYZ space, blah, blah, blah. Yeah. Okay, let me stop this recording.